when magnets are being discussed, magnets are a natural substance. They are like stone. Magnets are like a stone and they are available naturally. Magnetic substances are in our course too. They are attracted by a magnet, iron and steel. And obviously you take chemistry also. So you should know that steel is not something separate. It is a part of iron. It's a modified form of iron. Non-magnetic substances, all other substances except iron and steel, all other substances are non-magnetic. So copy this screen. Magnet is a natural stone. In our course, two substances are considered magnetic. What's the meaning of magnetic? They are attracted by a magnet. In our course, there are all other substances except iron and steel. All are considered as non-magnetic.
Okay.
Copy it?
Yes, sir.
Good. We move forward to our next title concept, classification of magnets.
Okay.
Heading is there, classification of magnets. In our course, there are two types of magnets. One are called permanent magnets and second is called electromagnet. Permanent magnets are those which are naturally found in the earth, and electromagnets are those which are made by electricity. They are electricity driven magnets. You have to now copy this screen.
Okay.
Have you copied it?
Yes, sir. Permanent magnets and electromagnets. Okay.
Now, the uses of electromagnets such as maglev trains, loudspeakers, relays, electric bells, industrial lifting magnets. So these are applications of electromagnets in our course. What are electromagnets? They are those magnets which use electricity. They are electrical power driven magnets. Now you have to copy this screen.
What is maglev trains?
Those are high-speed trains which you have seen in Dubai and other, which are not actually touching the track. They are supersonic trains, especially Japan. That is a magnetic elevated trains. These trains are actually magnetically energized. They do not touch the track, so there is no friction, and they move at a very high speed. Loudspeaker and relay will be discussed later in our course. Now, methods of magnetization. Give the heading.
Methods of magnetization. Okay.
Now, what are the methods of magnetization? The problem was there that natural magnets were never enough. Natural magnets were never enough to fulfill the demand. Magnets are so much in demand that the natural magnets were limited, just like petrol and diesel are natural products. But now they are in limitation. Their prices are increasing because they are not available by synthetic way. Now look at this introduction. I'm putting important methods are number one, single touch, number two, double touch, number three, using a direct current. You have to copy this list.
Okay, sir. So what is the single touch and double touch method?
I will be explaining it, but just first you copy it. Single touch method. Give the heading.
So 1 second, I was copying that. Done. Done.
Okay. Now I'm putting the single touch method. I'm putting the single touch method. Look at this method. I have placed the iron rod, soft iron rod on a surface. I have placed soft iron rod on a surface. Look at this bar magnet, which is touching the soft iron rod. Now I slightly slide it over and lift it. Just like when you rub something, like you rub your own hands in the winter, you rub this bar magnet, and when you rub it, the soft iron gradually acquire magnetism. The soft iron rod gradually acquire magnetism. So you have to copy this screen. You place a soft iron rod on a surface and a bar magnet over it.
Then for this thing, will it become a permanent magnet or a temporary magnet?
It become a permanent magnet if it is a steel. Iron gradually loses magnetism. You will find these soft iron magnetized rods in your school laboratory, which are half painted red and half painted black. This is called single touch method. Now right under it, that slide the bar magnet, slide the bar magnet
Okay.
slide the bar magnet over, slide the bar magnet over the soft iron rod.
Yeah.
After few strikes,
Yeah.
after few strikes, iron rod will be magnetized. Okay. Now this is called single touch method. It's a very slow method. Now give a heading double touch method. In double touch method, I have the iron rod, soft iron rod, and I put two bar magnets, one with north down and one with south down. And I move it like this. Half of the iron rod is covered by one bar magnet, and half of the iron rod is covered by the other bar magnet. So it is just like two people together pushing a car. So they will do the job a bit quickly. So this is called double touch method. You have to copy this screen. I just have to say Maghrib Namaz here. You copy this screen and I'm just coming. half of the rod is covered by one. Half of the rod is covered by one bar magnet and half of the rod is covered by the other bar magnet. It's basically a job divided between two bar magnet. So this method is relatively faster. This method is relatively faster and you can magnetize the rod in less time. Obviously, this method is not very strongly producing magnets. Now, this is called double strike, yeah, double touch method. Look at this. Hamad, are you there? Hamad,
Yeah.
are you? Can you hear me?
That got muted by itself only.
Okay.
I wanted to say, sir, these like the magnets produced by double touch are permanent or
Both, just first look at this. Any
Double touch method. Place a steel bar to be magnetized on two bar magnets as shown here. Now place opposite poles of two strong magnets at the middle of the steel bar as shown here. Move the magnets towards the opposite ends of the specimen, keeping the magnets inclined. On reaching the opposite ends, lift the magnets and place them back to their respective original positions. Repeat the process. The polarities developed at the ends are opposite to the polarity of the pole used for magnetization. Place some iron nails on the table. Now bring the steel bar near the iron nails. The steel bar attracts the nail, showing that it has acquired magnetism. Introduction. Magnetization is the process by which a magnetic substance attains magnetism temporarily or permanently. The methods used to magnetize a magnetic substance are single touch method, double touch method, electrical method of magnetization. Demagnetization is the process of removing the magnetic property of a magnet. The magnetism of a magnet can be totally or partially destroyed in the following ways: by rough handling, by heating, by induction.
we are now introducing a solenoid. Solenoid is a coiled wire. Look at this screen. Solenoid is a coiled wire. This is the output shape of a solenoid. So give the new heading, give a new heading, solenoid.
okay. Should I write this also? Solenoid is a coiled wire.
Yes, yes, copy it, solenoid.
Done.
Solenoid is a coiled wire. This is how a solenoid is made. I have coiled a wire over a rod of iron. Now, using a direct current method number 3, I have a solenoid and I have soft iron rod in it and I have a switch. I have a switch circuit, DC power, and when the switch is closed, electric current passes through the solenoid. After some time, the rod is magnetized. This is the most powerful method to magnetize something. It is much quicker because iron rod is ready to be magnetized by electric current. This method is very fast and you can get stronger magnet by this method. Now you have to give this heading. Now, you have to, Ahmad, you have to copy this diagram neatly.
Yeah.
You have to copy this screen. The diagram shows a solenoid with a DC power input. And remember, current is always shown from plus to minus. Ahmad, can you hear me?
Can't you hear me? Done.
Yes, I can hear you. Have you copied it?
That's it, done.
Okay, but I didn't hear it somehow again. The rod is magnetized. Now give a new heading, Fleming's right-hand rule. It's important. Give a new heading, Fleming's right-hand rule. Now, Fleming's right-hand rule is now in front of you. This is actually a method. This is actually a method to predict the North Pole. Now, the method says hold the magnet, hold the solenoid in your right hand such that these fingers are folded in the direction of current. Then if the fingers are in the direction of current, then the thumb will point in the north. I repeat, hold the solenoid in your right hand, hold the solenoid in your right hand, such that the fingers are folded in the direction of current. Then your thumb will be showing north. So this is how we can predict the direction of magnetic polarity. So after giving the heading right under it, that this rule is used to predict the magnetic polarity of a solenoid. Oh, next line. After changing the line, hold the solenoid in your right hand. Hold the solenoid in your right hand such that hold the solenoid in your right hand such that the fingers are folded in direction of current. The fingers are folded in direction of current. Fingers are folded in direction of current.
Yes.
Comma, the thumb will point in direction of north. Now give a new heading, methods of demagnetization. Methods of demagnetization. Now, remember one thing, that why we need this type of thing. After giving the heading, write under it that demagnetization is needed. Demagnetization is needed for different purposes. Demagnetization is needed for different purposes. Like removing the data from a media. For example, removing data from a media. So when you store data in a computer hard drive, you magnetize it. And if you demagnetize it, the data will be deleted. Important methods are heating, hammering, and using an alternating current. So these methods can be used to demagnetize. You have to now copy this screen. Have you copied it, Hamad?
Done.
Right. Now, look at the heating process. Heating is quite famous in our course, in our general life, sorry, that if you heat a magnetic system, it will actually destroy the data stored. This is a very common precaution. For example, data loss at high temperature, because temperature removes magnetism. So give number one, heating. Give number one, heating, and write under it heat energy. Heat energy can demagnetize a system. Heat energy can demagnetize a system. Now, this is common, and normally when we are dealing with mobile phones, gadgets, and other devices like electronic devices, you can hear that you should not be subjected them to a high temperature, because high temperature causes a data loss. You have to copy this screen now.
Yeah, done. Okay, sir, done.
Number two, hammering.
Oh,
So what is hammering? Hammering is hammering might be a strong word, but actually here you have to put the magnet. You have to put the magnet and gently tap it. It's like tapping. So when you tap an ammeter, a galvanometer, you can demagnetize it. For example, now write number two. Write number two as a heading, side heading, and write under it, place the magnet, place the magnetized material, place the magnetized material on place a magnetized material on a rigid surface. Place the magnetized material on a rigid surface. Tap it gently. Tap it gently. For example, you have to copy this example. You tap an ammeter, you can tap a voltmeter, you can find even some people who are tapping the calculator if they are not working. So this is called tapping. Tapping removes unnecessary magnetization. This is an ammeter, and we tap it like this. And this is used when you find that there is some magnetization in the needle. So tapping is a possible way to remove magnetization. Number three, using an alternating current. Now our solenoid is back. Our solenoid is back. Solenoid is there, but this time our input is AC. Solenoid is back, but this time the input is AC. Carefully see, the magnetized iron rod is inside the solenoid. And what we want to do, we want to demagnetize it. When the switch is closed, electric current passes through the solenoid. After short interval, now the magnet is gradually removed. After a short interval, we pull out the magnetized iron rod. this will, look at this screen carefully. This is how alternating current works. It will keep on switching. It will keep on switching the magnetic poles. It will keep on switching the magnetic poles, and you are trying, and what you are doing, you are pulling out the magnet. You are pulling out the magnet. This will demagnetize the rod. So what is the method? You need, when you want to demagnetize, the iron rod, you have to put it in, a solenoid, inside a solenoid. And once you put it in a solenoid, you have to switch on the current. Now what will happen when you switch on the current? Look at carefully again. This will happen. Alternating current quickly reverses the polarity, and you will be pulling out the magnet. This will demagnetize it. Okay, this is the concept. Now you have to give the heading. This is the heading. Number 3, using an alternating current. Let me know once you take the heading. Now you have to copy this screen. After giving the heading, copy this screen. Have you copied it?
Yes. Yes.
Iron and steel. This is our new heading. Give the heading. Now we keep it up to here. We left it on the heading. I have shared some digital resource with you on the WhatsApp. You please look at it after the class. These chapters we are doing now are the core difficult chapters in O-level physics. They need a very strong concepts, and that's why I'm sharing digital media things. So please look at this, and we will inshallah continue in the next class. Allah Hafiz.